Welcome to our deep dives today. We're going to delve into the mathematical world of Ferdinand Georg Frobenius.
Oh, a fascinating choice.
He was a prominent German mathematician,
Mm.
lived from 1849 to 1917.
Mm.
And while he's known for his work in diverse areas,
Right.
like elliptic functions and differential equations, we're really going to zero in on his profound impact on group theory.
A great place to focus, I think.
Yeah, we'll explore things like Frobenius groups,
Of course.
Sylow theorems, and even touch on Frobenius reciprocity.
All named in his honor, of course.
Exactly, all named after him. So to get us started, I think it's worth taking a look at the list of things named after Ferdinand Georg Frobenius Wikipedia article.
Okay.
It's quite extensive. It really highlights the breadth of his influence across various mathematical domains.
It really does, It's amazing to see just how much of an impact he had.
Yeah, and both of our sources emphasize the significance of group theory in Frobenius's work.
Absolutely.
So I was hoping you could maybe elaborate on that for our listener.
Sure. So Frobenius, he made groundbreaking contributions to the understanding of abstract groups.
Go on.
For instance, he provided elegant proofs of the Sylow theorems, but for abstract groups. Now, this was significant because prior proofs, they were limited to permutation groups.
Okay.
So by extending these theorems, Frobenius, he really broadened their applicability and deepened our understanding of group structures.
So he really built on that existing knowledge and kind of pushed it even further, expanded it.
Absolutely, and his contributions didn't stop there.
Right.
He also developed the concept of Frobenius reciprocity, which relates to group characters and representation theory.
Yeah, I came across that term as well, and I was hoping we could unpack that a bit further.
Of course.
It sounds quite intriguing, especially for our listeners.
Frobenius reciprocity.
Yeah.
Yeah, so it establishes a really kind of beautiful duality between the representation theory of a group and its subgroups.
Okay.
It essentially reveals a profound connection between how a group can be represented by matrices and the representations of its smaller constituent groups.
So you've got the representations themselves, but it's also how they interact with the representations within the subgroups.
Exactly. It's a key insight that links the global and local behavior of group representations, offering a powerful tool for analysis.
It's amazing how these seemingly abstract concepts reveal such deep connections.
It really is.
Within mathematical structures.
Mm-hmm.
And then, of course, we have the Frobenius groups themselves. The Ferdinand Georg Frobenius Wikipedia article. It defines a Frobenius group as having this specific type of subgroup, where the intersection of that subgroup with any of its conjugates outside the subgroup is always trivial.
Yeah.
Could you unpack that definition a bit further for our listeners?
Sure. So imagine you have a group, right? And within it, there's this special subgroup.
Right.
You take any element from the group and you conjugate this subgroup.
Mm-hmm.
You're essentially transforming it using that element.
Right.
If the only shared element between the original subgroup and any of its transformed versions is the identity element, then you've got yourself a Frobenius group.
Okay, and the Wikipedia article also mentions that the subgroup N,
Right.
formed by the elements, not in any conjugate of the special subgroup, along with the identity, is nilpotent,
Yes.
as proven by John G. Thompson in 1959. So that seems like quite a significant result
It is.
related to Frobenius groups.
Yeah, it reveals an additional layer of structure within Frobenius groups,
Okay.
highlighting the presence of a nilpotent subgroup. Nilpotent groups have special properties that make them easier to analyze, which provides further tools for understanding the intricacies of Frobenius groups.
So even decades after Frobenius's work, new insights about these groups were still being uncovered.
Absolutely. It speaks volumes about the depth and richness of his initial contributions.
Yeah, his ideas continue to inspire new discoveries and deeper understanding.
Mm-hmm.
Now let's delve into some maybe specific examples of mathematical concepts named after Frobenius.
Okay.
There are so many to choose from.
There are a lot.
The list of things named after Ferdinand Georg Frobenius Wikipedia article is quite extensive.
Yeah.
Really highlights the breadth of Frobenius's work.
It does.
It includes the Frobenius endomorphism, Frobenius normal form, Frobenius manifold, Frobenius method,
Right.
Frobenius covariant derivative,
Keep going.
and many more. Are there any specific examples from this list that stand out to you that you'd like to discuss?
Given our mathematical audience, let's delve into the Frobenius endomorphism.
Okay.
It's also known as the Frobenius map, and it plays a fundamental role in algebraic geometry and number theory.
Yeah, I remember encountering the Frobenius map during my studies.
Sure.
It involves raising elements of a finite field to the power of the field's characteristic.
That's right.
What makes it so significant in these areas?
Well, it boils down to this. The Frobenius map, it beautifully captures the structure of finite fields by raising every element to the power of the field's characteristic. It creates an automorphism, a way to map the field onto itself while preserving its structure.
Okay.
This seemingly simple operation has profound implications for understanding the properties of finite fields and their extensions.
So it's not just about the calculation itself,
Yeah,
but the insights it reveals about the field's inherent structure.
exactly. It's a powerful tool for probing the deeper nature of finite fields.
Hmm.
In algebraic geometry, for example, it helps us understand the geometry of curves and varieties defined over finite fields.
Okay.
And in number theory, it plays a crucial role in the study of Galois extensions and the behavior of prime numbers in these extensions.
That's quite remarkable. It's amazing how a single concept can have such wide-ranging applications.
It really is.
And another concept that highlights Frobenius's impact, but in a different domain,
Yes.
is the Frobenius method.
Right.
Ah, yes, the Frobenius method, which is used for solving differential equations. I recall it being particularly helpful for tackling those tricky ones around regular singular points. Could you maybe remind our listener about how it works?
Certainly, the Frobenius method provides a systematic approach for finding series solutions to linear differential equations.
Okay.
It essentially involves searching for solutions in the form of a power series multiplied by a specific factor, which is determined by the equation's indicial equation. This method allows us to tackle situations where traditional methods might falter, particularly when dealing with regular singular points.
So it's a way to kind of extend our solution-finding toolkit
Exactly.
beyond those traditional methods.
Precisely, and it's a testament to Frobenius's ingenuity in developing techniques to handle these more challenging scenarios. The Frobenius method has broad applications in various fields, from physics to engineering, where differential equations play a central role in modeling and analysis.
It's incredible how Frobenius's work touches upon such diverse areas of mathematics.
It is.
And has such a lasting impact on those fields.
It is, and it's a testament to his ability to see connections and develop elegant solutions that transcend specific domains.
Okay.
Another testament to this is the concept of the Frobenius norm, which finds applications in linear algebra and beyond.
Yes, the Frobenius norm.
Yeah.
I recall it being used to measure the size or magnitude of a matrix. But we already have the determinant for that purpose.
Right.
How does the Frobenius norm offer a different perspective?
You're right. The determinant provides a single number representing the matrix's scaling factor.
Okay.
However, the Frobenius norm provides a different measure.
Okay.
It involves taking the square root of the sum of the squares of all the matrix elements. In essence, it treats the matrix as a vector in a multidimensional space and calculates its length using a generalized Pythagorean theorem.
So it provides a way to, quantify the overall kind of magnitude of the matrix, considering all its elements collectively.
Exactly. And this concept has proven valuable in various applications, particularly in data analysis and machine learning.
Interesting.
For instance, the Frobenius norm is used in matrix factorization techniques, such as singular value decomposition, which plays a vital role in recombination systems and other data-driven applications.
It's fascinating how a concept developed in the realm of pure mathematics finds such practical applications in modern technologies.
It truly is. Frobenius's work beautifully exemplifies the interconnectedness of mathematics and its enduring impact on various fields.
So we've seen how Frobenius's contributions extend from abstract concepts like the Frobenius endomorphism to practical applications in fields like machine learning.
Yes.
It's remarkable how his work continues to resonate across diverse mathematical domains.
It is, and his legacy extends far beyond specific theorems and applications. It's about his approach to mathematics, his way of thinking, and his profound impact on how we understand mathematical structures.
I think that's a great point to maybe lead into the final part of our deep dive.
Sure.
We've explored some specific examples of Frobenius's work.
Yes.
Now, let's maybe shift our focus to the broader context of his legacy.
Okay.
And consider how his contributions continue to shape the landscape of mathematics.
Sounds good. Sounds good.
Now let's shift our focus to the broader context of Frobenius's legacy and how his contributions continue to shape math.
Yeah, you're absolutely right. Frobenius was more than just a prolific mathematician. He was a pioneer, and he shaped the way we think about mathematical structures. His influence goes far beyond just the specific results that he obtained.
Right.
It's about his approach to math,
Okay.
his emphasis on rigor, elegance, and his ability to connect areas of mathematics that seem totally different.
So his legacy isn't just about, like, the discoveries themselves.
No.
But it's the methods.
Yes.
His style of thinking, the way he approached these problems.
Precisely, he instilled a sense of deep understanding and a quest for connections that's influenced so many generations of mathematicians. His work on group representation theory, for example, laid the foundation for a field that is now crucial in things like quantum mechanics and particle physics.
It's remarkable how his work, rooted in these abstract concepts, has had such far-reaching consequences.
Yeah.
Considering the breadth and depth of his impact. It's kind of fascinating to think what a modern-day Frobenius might be focusing on in math today.
That's a great question. Given his penchant for connecting seemingly disparate areas, he might be drawn to the interface between mathematics and fields like biology or computer science, where mathematical tools are being used increasingly to tackle really complex problems.
Yeah, it's exciting to imagine him kind of delving into areas like bioinformatics, maybe using algebraic topology to understand the structure of proteins.
Exactly.
Or applying his insights from representation theory to develop new algorithms for machine learning.
Absolutely. Or maybe he would be captivated by theoretical physics, where deep mathematical structures are believed to underpin the fabric of reality. He might explore the connections between quantum field theory and algebraic geometry, trying to unravel the fundamental nature of space, time, and matter.
It's really inspiring to think about all those different possibilities.
It is.
And Frobenius's legacy reminds us that math is a constantly evolving field, always pushing the boundaries of knowledge and understanding. And his work continues to inspire mathematicians to explore those frontiers, looking for those new connections and elegant solutions to these challenging problems.
This deep dive has been a testament to that. We've seen how Frobenius's work, rooted in these abstract concepts, has just blossomed into this rich tapestry of interconnected ideas with implications across so many fields.
It's been awesome to explore this tapestry with you.
It has.
And uncover the beauty and depth of Frobenius's mathematical world.
It really has.
Hopefully our listeners are leaving with an appreciation for his contributions and a sense of wonder about the possibilities that math holds.
Yeah, the journey of mathematical discovery continues.
Absolutely.
And Frobenius's legacy is like a guiding light, encouraging us to embrace rigor, seek those connections, and just keep pushing the boundaries of our understanding.
Thanks for joining us on this adventure.
Of course.
Until next time, keep exploring, keep questioning, and keep diving deep into this fascinating world of mathematics.
Yeah, it has. It's been great to explore this tapestry with you and uncover Frobenius's mathematical world.
It really had.
And hopefully our listeners are leaving with a sense of appreciation for his contributions. And a sense of wonder about math.
Definitely. And, you know, the journey of mathematical discovery continues.
Oh, absolutely.
And Frobenius's legacy is like this guiding light for us, encouraging us to embrace rigor, seek connections, and just push the boundaries of what we understand.
Well, thanks for joining us on this mathematical adventure.
Of course, it's been a pleasure.
Until next time, keep exploring, keep questioning, and keep diving deep into this fascinating world of mathematics.